Personal finance practice problem using Excel. Mortgage rate, APR, break-even point. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side. I'm going to populate that into the blue area on the right-hand side, comparing and contrasting two different loan scenarios. The first in which we have the loan. We're imagining this is how much we need in order to finance the purchase. And we're going to say the closing costs are the $1,000. The interest rate is 7%, 30-year loan. We're going to compare and contrast that to another loan over here that is for the $100,000. That's how much we need. But the closing costs are going to be the costs of the loan, $4,000. So a difference there, and we have a different interest rate. So this is when the APR can be a useful comparison to use. And then we also want to do a comparison if we don't have the full extent of the loan, a break-even analysis to determine when it would be the case, at what point would it be the case that paying this $4,000 up front would be worth it, given the fact that we're paying that basically up front, meaning if we were to sell the home in something other than the full extent of the loan, the 30 years, we may end up in a situation where we wouldn't want to be paying the $4,000 upfront, even though we may have a lesser APR in that calculation. So we'll calculate the APR, which is the general standard that we would use if we were holding on to the home for the full extent of the loan, in this case 30 years. Then we'll think about the break-even point, at which point the two loans basically kind of even out, and we'll discuss that further as we go. So let's do the first one here. We did the calculations before in a prior section related to the loans and the APR, so we'll do it a little bit more quickly here. If you want some more in-depth on them, take a look at the prior presentation. So we got the $100,000 loan, closing cost at the $1,000. Let's first think about the number of periods. We have a 30-year loan, 12 months in a year. It's a monthly loan, so we're going to take that 30 years times 12 to get 360 months of the loan. Then we want to think about the payment. We're going to have the Pmt formula with the costs included. In other words, the loan would be for the $100,000, but we have another $1,000. So in essence, we have to pay for the loan to get the home in this case, and we have to pay another $1,000 just to basically finance the thing. Therefore, our loan amount is going to be $101,000 that we're going to be needing. So we're going to say, all right, that means that the payment's going to be negative PMT, shift 9. The rate is going to be the 7%, but that's a yearly rate, so I'm going to take that and divide it by 12 to get the monthly rate, comma. Number of periods is going to be 360, 30 times 12, comma. And then the present value is going to be the $100,000 loan plus the closing cost of the $1,000 for the $101,000. Giving us the 672, about adding some pennies, going to the number group, adding a couple decimals, 671.96. So then we have the APR for the monthly APR calculation. So we're going to do this using our rate function, which is going to be equal to the rate shift 9. We're going to pick up the number of periods, which once again will be 360, comma. The payment is what we just calculated above in cell E1, and that needs to be negative, by the way. It needs to be negative of that calculation we had in E1, comma, and then the present value, and this is where kind of the trick component is here. We're not going to be picking the present value of the 101, but simply the 100,000 to fold in those closing costs into the APR rate, this being the monthly rate, number group, percentifying, adding decimals. We then can make that the yearly APR. So we're going to say APR for yearly, and this will be then equal to that monthly rate times 12, adding some decimals, number group, percentifying it, and then adding some decimals, 7.10 that we have here. So if we were to do our amortization table, let's just plug this into an amortization table. We're going to say 0, 1, 2. I'm going to copy those or use our autofill feature, grabbing the autofill handle dragging down for 360 payments all the way down. We will center that, alignment and center, so there we have it. Then I'm going to put the balance over here in the balance column in period 0. We're going to have the loan amount plus the 1,000 because we're going to have to finance the amount we need for the loan plus the another $1,000 that we needed to set up the loan. The payment is going to be equal to the amount we calculated for the payment right up top. Going to say F4 on the keyboard, $ before the E and 1. You only need a mixed reference, but I'm going to use an absolute one because it's easier to do. Then I'm going to say this is equal to the 101,000 prior balance times the rate. Now we're not looking APR rate. We're calculating here this 7%. So we're looking at the 7%. So a little bit of a tricky thing there between those two rates because, well, I won't get into that now. We talked about that last time. So we're going to say F4 on the keyboard to make that an absolute so I can copy it down, $ before the B and 3. And then we're going to take the different, oh, hold on a second. That's for a year. Double clicking on that. Then we got to divide that by 12. We need to divide that by 12 because this is per month. So we got the yearly amount divided by 12, monthly amount. Now we're going to say the payment is equal to the 672 minus the interest, the 589 about. Notice rounding is involved here. Then we're going to take the difference, this being equal to the 101 minus the 83, enter. Now I'm going to copy this down, selecting these 4 cells. You could do that by just double clicking over here. We could double click and it'll copy it all the way down. We're going to double check the double click. After double clicking, we're going to double check that it gets to 0 at the bottom, which it does indeed. So we're good. So I'm going to pull this all the way back up. So that's our first one. Now we might think about the total amount of the cost that we've had so far. So we could do another running balance. I could say, well, you know, the cost of this is really the $1,000 plus the payment that we are putting into place at this point in time. And I could then say this is going to be equal to the one above it plus the payments that we're going to have. Hold on a second. We're starting off at the 1,000. 1,000 is our starting kind of cost. Then we have the 1,000 plus the payment. And I can run that balance all the way down as well and think about kind of the cost of the loan, which will become relevant as we do our comparison. So the total cost is really this 240. The payment. We got the payments that we made plus the $1,000 that they charged us over and above the amount that we needed. Or in other words, if, for example, we finance the entire home for the $100,000, which generally you would need a down payment, right? But let's imagine we got the loan for the full amount and then we turned around and sold it for a sales price of $200,000. Then we would say that would be that. I'm not going to calculate the gain. I'm just going to calculate it net of the loan, right? The loan that we had, if was right after the purchase, instead of 100,000 is of course 101,000. So the net amount we would then have is the 200,000 minus the 101 after we paid off the loan that we had to take out in order to right up front. So the loan company took the money, right up front and tacked it on, added it to the loan is what I'm trying to get at. So then if I compare that to our second scenario over here and we say, okay, well, what if we had another scenario where we had the $100,000 loan and then the closing costs were $4,000, but the interest rate is only 6.5. So obviously the closing costs are higher, meaning the company that sets up the loan is going to take that money sooner. They're going to get paid sooner, but they're charging a lesser interest rate at the 6.5. Now, when I compare that, it's hard to compare because I'm like, well, I got a lesser interest rate, but then I got this cost, and I got to pay that cost up front, but I'm not really paying it because I'm going to add it to the loan balance, and then I'm going to pay it over 30 years, but I might not even have the loan for 30 years because I might be planning on selling it after like 10 years or something like that. So it's a little confusing. So the first thing we want is a comparable APR. That's why we do the APR. So we can then say, okay, well, the periods in the month is once again going to be the 30 times 12. So we got 360 periods. Same calculation, payment with the costs. is going to be equal to the payment calculation. I'm going to say negative PMT shift 9. We'll pick up the rate at the 6.5 divided by 12 because that's the yearly rate. We want the monthly rate, comma. Number of periods is going to be 30 times 12 or 360, comma. And then the present value is going to be the 1,000 plus the 4,000 because we're going to have to finance the 104,000 given the fact that they're charging us that 4,000 of the costs. So then we're going to go to the number group, add a couple decimals. So the payment is at the 657 versus before you can just see we were at the 671. So the payments are better, of course. We have a lesser amount of the payment due to the lesser interest rate, but they tacked on that 4,000 that the loan company just took like right up front on it. So we're going to say, okay, well, what's the APR then? The APR for the monthly is going to be monthly APRs. Our rate formula equals the RATE shift 9. The number of periods, once again, 30 times 12 or 360, comma. The payment is going to be negative of the amount above. It's got to be negative or you're going to get a error sign or something. And then the present value, once again, I'm not going to pick the 104 this time. This is the kind of tricky point. We're just picking the 100,000 to get the APR so that we can roll in the costs into 1% number. The number group percentifying it, this would be the monthly APR. So then we want the APR for the yearly, which is just simply going to be the monthly APR times 12 to bring us the yearly. Number group percentify, add a couple decimals. We're at the 688. So now we're at the 688. Now, so notice that this APR now is less than this. So you would think even with rolling in then, and it would generally be true, even with rolling in the 4,000, you have a lesser APR, a lesser cost over the extent of the loan, which is extended over a 30-year time period. So that, however, so if you were going to live in the home for 30 years or hold on to it for 30 years, and that's your goal, which it may well be, then you would think the APR is going to be a good number. However, if you're saying, hey, I think I'm only going to live in it for like 10 years and then I'm probably going to sell it or something like that, then just to emphasize that point, like same example we saw last time, like if you were to sell it now, let's say we financed it and it cost us, the whole cost of it was for the 100, it was 100,000 cost, and then the company added on that 4,000 charge for the loan. So let's say we financed the entire thing, and let's say we just turned around and we were able to sell it like the next day, the sales price for the 200,000. But then we have to pay off the loan, and of course the loan at this point in time is now not just the 100,000, but now the loan is the 100,000 plus the 4. So the net amount we would get, even if we could turn around and sell it, the next day, would be 96, right? Because they increased the amount of the original loan of that 104. They put it right up front, even though it's costing us less in terms of monthly payments. So we have this, so we have that difference, basically, that difference is taking place. And if we're not going to hold the loan for the whole 30 years, then the question is, well, when are the two loans going to basically be even, right? And that's where the break-even point. So you can see it a couple different ways. I'll do it with an amortization table, and then we'll do a calculation over here, which might be a little bit easier to see. But I think the amortization table helps us understand it. So let's do the amortization table again. We're going to say 0, 1, and then I'm going to select these two. I'm going to copy that all the way down. 360 payments down here, 360. Going to center that. Let's center that payment, and let's put the balance first here. The balance is going to be the 100,000 plus the 4,000, or the 104,000. The payment is going to be equal to the 657.35. I'm going to select F4 on the keyboard, making it absolute, $ before the R and 1. Interest will be calculated as the balance times the interest rate, not the APR, but the interest rate. F4 on the keyboard, so we can then copy it down, divided by 12, because that's the monthly rate, and we have the yearly rate over there. We need the monthly amount. So we have that. The difference then between the two, the payment and the interest, is going to be 94 for the first payment. The balance at the 104 minus the 94 means the reduction in the balance will be down to 103,906. Selecting these four, double-clicking the autofill, that's going to drag it all the way down. Let's check and see if it goes down to 0. It does. It looks like we've calculated that properly. So now if we think about our total cost here, we could say, okay, well, the cost is really, they charged us this extra $4,000 up top. That's going to be our starting cost. And then we have the $4,000 plus, the payment. This is how much we're actually, paying. These are our total costs or payments. So we're going to then copy that down. I could copy that down all the way down to the 360. And so that would be the total then. So in other words, that would be the total amounts that we paid, right? Which would be the column 1 here. We paid the $657.35 that many times, which is the 236,646 plus another $4,000. So in other words, we paid, if we do this thing all the way for the full term, it would be this times 360 plus the 4,000, that they charged us for over and above what we needed, which was the 100,000. Now, what we're looking for is when the loan balances are equal, or when these two costs kind of even out. So I could take the difference now between this number, the total paid, and this number. You can also take the difference between the loan balance, and I'm going to say, okay, that's the difference of the 3,000. If I copy that all the way down, copy that difference all the way down, we're looking till the point when it flips. So it flips, right? And that happens somewhere right here between payment 205 and 206. And you can see that's when the loan balances kind of even out at that point in time, right? So we're going to say the loan balances are around 138,751, 139,423, 138,757, 139, right? So that's basically somewhere in between those 2 months is kind of our break even. So I think intuitively it's kind of nice to line these up, and you could see these this way, because these amortization tables are somewhat complex. You might be able to see calculations on this online as well, but it's probably not going to be quite as clear to you when you do it that way. So then the other way you can do this calculation, just in terms of a mathematical calculation, is we could say, okay, let's just do the math on the break even and think about it. We could say, well, let's look at the difference in costs. The difference in costs, if I look at loan 2 cost versus loan 1 cost, we could say loan 2, they're charging us $4,000 versus loan 1, they charged us the $1,000. So the difference then is going to be the $4,000 minus the $1,000, or $3,000 difference. So this is the difference in cost. That's what they charged us over and above the amount that we needed to finance the home, and they tacked it on and then just tacked it on to the loan. I'm just going to indent those two things, and we can compare that then to the difference in payments, which should even itself out after a while. And this one, I'm going to take the loan 1 payment, which is larger due to the difference in the interest rate, and then the loan 2 payment, which is less. And so we're going to say this is going to be loan 1 payment, which we calculated to be the $671.96. The loan 2 payment, which we calculated to be the $657.35. The difference between those two is around 15. Let's add some decimals, numbers, couple decimals. 1460. This is the total difference in payments. Let's indent these. Alignment, indent. Let's indent this one again. Indent. Let's put an underline here, here, and here, just to make it look nice here, just to make it look nice. And then we're going to say, okay, the break even in months is going to be that $3,000 divided by that difference in the payments, which is 14.6 about. So we're about 205, add in some decimals, 205.41 months. If I say months in a year is 12, we got the break even in years, which is going to be equal to the 205.41 divided by 12, or about 17.12 years, right? So that would be, so that, and you can see that 205.41, 205, 206 is our number of payments all the way down here, and that's when it flips. So in 205, 206, that's when we have approximately, somewhere right between there, approximately the same loan amount. So you can imagine then at this point, if we sold it for the 200,000, we would have in essence the same loan amount here, right? So in this case, if you're saying, okay, well, if I got a 30-year loan and I locked in the rate for the entire time period, but I don't think I'm going to hold it for 30 years. Am I going to hold it for something like 15 years, under, something under 10 years or something like that? If so, then it might not be worthwhile paying the $4,000 up front, even though I'll have a lower APR, because it's going to result in that difference happening when I make the sale. If I sold it for the 200,000, then I got to pay off a higher loan amount because they tacked it on, and I hadn't yet paid it off yet because it's going to be calculated over the life of the loan, over the 30-year loan period. If, on the other hand, I expect to have this thing forever for 30 years and so on, and that's my home, then then you're generally going to be okay with the APR. The lower APR is generally the place to be.